So we are going to extend this H parameter model for transistor so that we can analyze the transistor as an amplifier using the H parameter model in a more effective way. So we can easily find out where is the Q point, whether it is in the active region or cutoff or saturation. So where is the position of Q point. So this the H parameter model makes our job very, very simple. It is going to clearly, we can from the H parameter model, we can easily find out the parameters of the transistor. So H parameters have a lot of advantages. You see, first H parameters are real numbers. So they are real numbers up to radio frequencies. They are very easy to measure because they are either dependent on voltage or current. Okay, so they can be easily got from the transistor characteristics. So once you draw the input output transistor characteristics graph, you can get all the H parameters easily from those graphs. They are very convenient to design and analyze a circuit. So analysis of transistors are very, very easy using H parameter model, and they can be easily convertible from one configuration to another. If I have a common base, I can easily convert that into common emitter very easily. And this H parameter model will be readily supplied by manufacturer. So in the market, if you are going to go and buy a transistor from Ritchie Street, he will be giving a specification. Those specifications will be in terms of H parameters only. Okay, very, very important. H parameters are in terms of analyzing the behavior of transistor amplifiers. And this is the diagram for common emitter configuration. So you see emitter is grounded, input is given to base, output is given to collector. So input voltage is VB, output voltage is VC, and you can write the H parameter equation. VB equal to HIE IB plus HRE into VC. IC is equal to HFE IB plus HOE into VC. From where did these two equations come? The very basic equation of H parameter model. I am just rewriting that for common emitter configuration, nothing else. Okay, if you know the input voltage, output voltage, input current, output current, you can easily write these two equations from the H parameter model. So any doubt in the basic H parameter model for common emitter configuration? I have not drawn for CB and CC because we are not going to study about them. We are going to narrow down now and we are going to focus only on CE, common emitter amplifier only. Okay, that's why I am not discussing about common base and common collector. So any doubt so far in H parameter model you are having? How to understand H parameter model? It is not difficult, it is very simple. So you see these two equations you have to remember. V1 is the input voltage. Here the input voltage is VB. So I replace V1 by VB. Output voltage is V2. Here VC is the output voltage. I replace V2 by VC. And since it is a common emitter configuration, I will be having HIE, HRE, HFE, HOE. All will be suffixed with E because it is a common emitter configuration. This is the typical values for H parameters for all the four configurations. This you should have studied in electron devices itself. Still, I am projecting this to ensure that you can compare and see which configuration is better. So usually first one is input impedance. Input impedance should be very, very large. So input impedance is very, very large for common collector and common emitter. HR, reverse voltage gain. Reverse voltage gain should be very, very small because forward voltage gain should be large. So among these three things, the reverse voltage gain is very, very small for common emitter. Current gain 51.98. So current gain is somewhat higher for CC and it is almost same for CE. And output admittance should also be, output resistance should be high. Okay, output admittance should be less. So that you see common base is having the very, very less output admittance. So these H parameters will logically say what is the value for the common emitter, common base, and common collector configuration, whether those values are justifiable or not. These values are given by manufacturers. So once they develop this BJT amplifier, they will test the BJT amplifier and they do a lot of experiments and they come to a conclusion that this transistor is having a HIE value of 1100 ohms. So that will be printed in the data sheet and given to you when you buy the transistor. And this is H parameter, and